All right, hello everyone. Thank you so much for being patient. My name is Catie Tobin, and I am the Microplastics Researcher for Clean Ocean Action. And I want to personally welcome you to the Exploring Microfiber Pollution, Sources, Environmental Impacts, Potential Solutions, and Next Steps webinar. It is my pleasure to introduce Rachel Sarnoff, the Executive Director of the Gyres Institute.
Hi everyone. Thank you all so much for joining us for this important conversation about the sources, potential solutions, and the environmental impacts of microfiber pollution. So microfibers really have been at the forefront of the plastic pollution conversation since about 2014, when studies started to emerge that showed that plastic microfibers were polluting our oceans. In 2014, Patagonia commissioned a study that found that a single fleece jacket can release as many as 250,000 plastic microfibers when washed in a machine. So just like plastic microbeads, which Gyres first discovered in 2012 in the Great Lakes, plastic microfibers are so small that they escape water filtration systems. And basically, you wash them, they go straight from that water into the water table and potentially up the food chain and onto our plates. So we're so honored to be hosting this conversation today with Clean Ocean Action and the EPA's Trash Free Waters program. And now I'm going to turn it back over to Catie to introduce all of our panelists. Thank you.
Thank you, Rachel, and thank you. It's been an honor to host this as well with Gyres. I will be guiding us all through this webinar as we make stops along the way to hear from experts in the field as we discuss the problem and possible solutions regarding microfibers. I encourage you all to type questions that may develop over the course of the webinar into the chat box, which you should see on your screen, and I will be going through those throughout the presentation for the Q&A after the presentations are complete. So we'll be doing the question and answer at the end of the webinar. This webinar was really born out of curiosity. A few of us are part of a microplastics working group, and we noticed this emerging area of microplastics specific to microfibers that we wanted to explore further. As we read more and spoke to experts across sectors, we recognized an opportunity to bring together interested parties to investigate the latest research and actions that scientists, companies, policymakers, and the public are contemplating, as well as we all seek solutions to microfiber pollution. I would like to personally thank Leah Colabello, Valerie Howell, and Adam Saslow, who have worked tirelessly over the past several months to make this webinar possible. And we're going to hear from Beth Jensen. Beth is the Senior Director of Sustainable Business Innovation for the Outdoor Industry Association, and she will be discussing potential leverage points from microfibers. So Beth, feel free to take it away.
So I represent Outdoor Industry Association. You can move to the next slide. We are the trade association that's based here in the US. We do have global membership though, about 1,200 member companies globally, representing the outdoor apparel, footwear, and gear industry. So many of our highest profile members, I guess you could say, include Patagonia, the North Face, Columbia Sportswear, and other companies. So we represent the full supply chain of outdoor apparel companies, and we have three pillars of work that we work on. We have a government affairs team. We have what we call our outdoor foundation, so our nonprofit that works to get youth into the outdoors, the next generation of outdoorists, so to speak. And then our third key pillar is sustainable business, and that's the area that I run. So you can move to the next slide. Yep, move on. So within the sustainable business work, I manage a group called the Sustainability Working Group. And that is a group of about 150 of these leading outdoor brands who are collaborating around supply chain sustainability topics. So everything from putting together a general sustainability measurement platform called the HIG Index, to looking at specific chemicals management issues and how to manage chemistries, including things like durable water repellent chemistries. And then now this microfibers issue has become a really important topic for our group, and one that we've been working on since about, really more actively since about 2014. As was mentioned, was sort of when this issue became more in the public eye. So moving on to the next slide, please. We have a couple of key points that we're really considering as we look at the context of this issue within the outdoor industry. really the biggest thing that I want to get across is this is not just a fleece jacket issue. So I think the outdoor industry is really being looked to as sort of a leading source of this microfiber pollution. I think, as we all know, the apparel, the general apparel, broader apparel industry globally is much larger than just the outdoor sector. And so we certainly recognize that we have a role to play, and we're actively seeking solutions, which I'll talk about in a minute, and trying to better understand the leverage points of this issue. But we also recognize that we need to involve many other partners and industries and sectors in this effort as well. So as you can see the list there below, the broader apparel industry, the industrial textile industry, carpets and so forth, tires. A recent IUCN report just came out a couple of weeks ago showing that between tires and textiles, those two sources account for 2/3 of all microfiber pollution. And that was a report from IUCN, which is the International Union for Conservation of Nature. And so not just outdoor and not just tires, but then, what other role do home washing machines have to play? Or, think about all of the washing of clothing that's happening in developing countries as well, and how does that contribute to this problem globally? Consumers, and how can we educate them about perhaps washing clothes less, or some potential solutions that they can employ? What does the industrial washing sector have to play in this? And then what role do wastewater treatment plants themselves have to play in this as well? And I have a stat up here as well that we have several studies that we've been looking at within the outdoor industry that show that between 65 and 99% of microfibers are captured by wastewater treatment systems. The 98 to 99% figures are coming from, we saw a source in Michigan, a study that was conducted on several wastewater treatment plant sites in Michigan, as well as a site that was studied in Sweden. And then some of the other numbers are coming from places like St. Petersburg, Russia, and Spain, and France, and some other areas that we've seen data come in as well. And so this is one of our efforts within the outdoor industry, is really to try to understand more effectively the sources and causes of this microfiber pollution issue, and all of the different stakeholders that need to be involved in this issue, and that we'd like to partner with, to make sure that we have a better understanding of this issue in a data-driven manner, to help our companies and the product designers and developers sitting at their desks across the world trying to make product most responsibly, providing them with the information that they need to make more informed decisions about the fabrics perhaps that they're choosing. So you can move to the next slide. So a few challenges just to highlight. This is a relatively new issue in the broader scale of the supply chain of apparel and textiles in general, and really highlighting this lack of data that we have right now to understand the root of this problem and its sources and causes, and what role does the outdoor industry have to play? What role does the broader apparel industry have to play? What role does the broader textile industry have to play? And then what role do all these other stakeholders that I've been mentioning have to play in this issue as well? One other thing that we've been, as we've been speaking with our partners and different NGO organizations and scientists and folks like the Ocean Conservancy and others who've been providing us with great technical information on this topic, one of the things that we've been hearing as well is that current spectrometry technology is limited as well to be able to really rapidly determine, or efficiently, I should say, determine the difference between different types of fibers that they're looking at. So whether it's a cellulosic fiber versus a synthetic or plastic fiber, and so that's one other challenge in this issue as well. And then, as you can see by the number of panelists that we have on this call today, there are many different organizations and groups starting to work on this. And to use sort of an American-based terminology, we've been talking about it as sort of a Wild West type of issue right now, just because there are so many disparate groups working on it, which is a good thing. But we're hoping that ultimately we can come together and make sure that we're not duplicating efforts, and really all kind of harness our energy in the best and most effective way to try to get after this issue and improve the situation. So the last thing I'll say is, many of you in the US have been tracking the microbeads ban that was signed into law by President Obama a couple of years ago now. I think it was at the end of 2015, formally signed. clearly the textile industry has we're in a bit of a different situation than microbeads and the personal care industry, in that microbeads were not essential to the functionality of that product. It was sort of a nice to have, thing that could be, relatively easily removed from those products. I think what we're looking at here with the apparel and textile and tire abrasion that's contributing to this as well, and all these different sources of microfiber pollution, it's not as easy as a simple ban. It's going to require more in-depth research into what types of fabrics shed more, what are all these different factors that are coming into play that are creating microfiber pollution. So you can move to the next slide. This is just a diagram that we've been using internally that one of our group members from the Canadian retailer Mountain Equipment Co-op, or MEC, put together, really for us to try to have a common reference point as an industry around the potential leverage points where these microfibers might be entering the system. So everything from material engineering to textile manufacturing through to home laundering and wastewater treatment plants, and then of course into the broader waterways and oceans. And then also considering the fact that even if microfibers are captured at wastewater treatment plants, are those then, is that sludge then going back into the agriculture system by being spread, as fertilizer or that type of thing, on fields, and then re-entering the water system that way. And so that's a whole other, area that I think that we need some further data and information on as well. So, and these slides will be available later, I'm told, so you can take a look at this and ask any questions toward the end of this webinar or offline. So getting to my last slides here. And I'm not going to go through all of these questions and read through all of them here on this call, but just so that you can all see the great number of questions that we have as an outdoor sector and really as the broader apparel sector as we've been talking about this, and all of the different questions that we feel like we still, in many cases, need answers to. And that's really what we're focusing right now as an industry, is trying to articulate what those key questions are, and then who are the right research and other stakeholder partners to help us get after the answers to those questions. So you can move on. And so the next steps for our task force, specifically within the outdoor industry and our sustainability working group, are that we're going to continue our efforts, which we've really been undertaking proactively for the last 2+ years, to reach out to other industries and stakeholders and groups that we know are part of this system and part of this issue, so that, again, we can combine forces and collaborate to make sure that we're not duplicating efforts and we're really all effectively trying to address this problem. We are seeking to inform and collaborate on research projects that are already happening. So as mentioned earlier, Patagonia, one of our member companies in this task force, engaged in one of really the first studies that look directly at effects of front load versus top load washing machines, as well as effects of aging of garments on shed rates. And those results are available publicly. That study was done in concert with some students at the University of California, Santa Barbara, Brennan School of Business, Brennan Environmental School. And so that was one of the first studies that kind of gave us some good information on this topic. And so now we're looking to expand on that research and to help answer all those other points that we had in the previous email, or in the previous slide, excuse me. And really partnering with those research organizations that are already engaging in research and try to help direct that research to answer those questions that we have as the textile and apparel industry. And then really the last thing is to lay out the industry's key data gaps. So try to really articulate the needs behind that list of questions on the previous slide, and put it in sort of a research brief format, so to speak. And we have an existing format for this that we've used for previous projects that we're looking to put together, again, to really articulate the needs that we have as an industry and hopefully help researchers and other groups understand the real needs that we have that are preventing us as an industry from making more informed decisions right now, and really moving towards specific solutions, because we don't have quite all the data in hand yet, but we're trying to do what we can to move toward those solutions in the interim. So next slide, just a few resources. We do have a priority issues brief, we call it, on microfibers, some blog posts and other resources on our website. The address is listed there. And then we've also been collecting all of the different information that we know about in terms of the different organizations and research projects that are already happening, various innovative solutions, various filters that are being developed to put on washing machines, and then different bags, clothing washing bags, Guppy Friend and others. I think they're going to be speaking here as well. Just trying to catalog all of those different solutions and efforts and research that are happening now into one library. And we have that document already put together. And if you'd like to have access to that, you can email me after this webinar, and we're happy to share that link with you. So you can go to the last slide, my email address will be there. So, and I think we'll leave time for questions after the call. So thanks.
Great, thank you, Beth. And as Beth mentioned, it's important that as we continue to develop questions to direct future research, it's also important to discuss and make solutions in concert with those questions. So we're going to be talking about some of those solutions today. So we're going to be hearing from Sophie Mather, a material futurist with Biovation, and she'll be discussing innovative textile solutions.
Yeah, so I'm going to be talking about how we can start to think about how we can re-engineer microfibers to actually change the industry here. So if you can go to the next slide, please. So I wanted to look at the bigger picture to start off with. When I started my actual piece of work late last year, there was quite a lot of work already being done at the measurement level with regards to marine and various different industries. And then there was emerging stuff happening at the capturing level as well. And I think we're going to hear about more of that today. But what I really was interested in is how we could start to re-engineer textiles to prevent this microfiber shedding issue happening altogether. So if you want to go on to the next slide. So a lot of the papers that we're reading today start at the garment level, and you can see there on the right-hand side where people have taken garments, they've taken them into lab situations and started to look at the amount of fibre shedding that's coming from different garments. The difference in the work that I'm actually doing is starting at the polymer level, looking at polymers, different polymers and recycled versus virgin, different yarns, and looking at things like cross-section, different yarn sizes, the effect of different additives into the polymers, and then how that corresponds to fabric as well. So really looking much further back, so from bottom up, and how the effect of different situations start to create different fatigue with regards to our textiles, and how that can have an end impact on fibre shedding. If you want to go on to the next slide. I'm just going to skip through a few slides, so if you keep going, please, Steph. And again, and again. Okay, if you stay on this slide. What I wanted to do here was show you a couple of images to really help you understand why, to a point that Beth made, it's not just about fleece. I really feel this problem is deeper than that. So this SEM image here in the middle is a piece of fabric after martindale abrasion. And what we understand about polymers is they don't actually kind of fragment in a very unified way, but actually what is happening is they kind of break off and fragment in different sorts of ways and different sizes. So when we're looking at some of the earlier papers and we're seeing numbers of fibers that have been counted after wash testing, I actually believe that there's going to be far more waste coming off fabrics in different ways as the polymers and yarns start to fragment in different ways. The image on the right hand side is biaxial fatigue damage that's happened to a filament yarn after a pill has formed on that fabric, and the pill has then fallen off. So again, another way that those yarns are starting to fragment and parts of them actually shedding during the wash and wear of those garments. If you want to go on, please. And again. Okay, so this is a work plan that goes across work that myself and the European Outdoor Group are doing, and both of us are working in conjunction with Leeds University. What we wanted to do here is have two pieces of work that worked kind of in conjunction with each other. So I will be working from the bottom up, and the European Outdoor Group is working from the top down. So if I talk a little bit here about the work that I'm doing, we've already conducted desk-based research to give us the kind of ground-based kind of understanding of where we wanted to take lab-based samples. As far as the sampling, we're taking polymers, different sorts of polymers, different sorts of yarns into the lab to actually understand them a lot better with regards to the different processing criteria that they're under, and also the different conditions such as aging and laundering that those yarns and fabrics would be under in general consumer wash and wear. We're correlating that with the top-down work that's going on by the European Outdoor Group that are looking more at the amount of fibre shedding that comes from different fabrics and investigating how different sort of shedding mechanisms actually happen on these different fabrics. What we're doing is making sure that the fabrics that go in the top-down piece of research correlate with the yarns that go in the bottom-up research, and together we'll be creating this database of results that will create this story from the yarns all the way up to the fabrics to help us really understand at what stages the fibre shedding is starting to happen. From that database of results, we'll be creating this textile engineering toolkit with the intention that it's going to be used across brands, retailers and supply chain partners to help the industry inform how we can better engineer our fabrics to prevent that fibre shedding. And longer term, we're actually looking to re-engineer polymers, yarns and or textiles so we can collectively prevent fibre shedding. If you want to just go on. Yeah, so I've started a crowdfunding campaign in support of this work, and we're currently at the lab-based stage. So if anybody wants to know more information about it, they can hop on that website.
Great, thank you, Sophie. And I encourage everyone to put their questions in the Q&A box. I will definitely be checking them throughout the presentations and pulling from them so that I can ask them at the end. So we're actually going to revert back into the beginning of the agenda real quick. We have Marcus Eriksen back on, and I believe his sound is working. Marcus, do you want to just check your audio real quick?
Yes, can you hear me?
Yes, I can. Perfect.
Oh, perfect.
So we're going to go back to your slides and then you can take it away.
Okay, so real quick in 5 minutes, I'll give you a quick rundown on some of the science and the work 5Gyres has done and what some of the sources might be. So first, you can see the first slide, that pathway from textiles, lost in the environment, all the way to the food that we eat. I think that's common knowledge. But if you look back to the work that we are doing, what we are discovering out in the environment. Let's see if you can advance to that next slide. So next slide is Arctic 2016. So we were in the Arctic this past summer for a couple of weeks looking at microplastics, working alongside the Vancouver Aquarium, and we're still processing our samples from there. We found microplastics on the surface. Vancouver Aquarium was sampling just below the surface, about 4 meters. Next slide. And you can see what they found were abundant fibers. And it kind of fits with our sort of hypothesis that, you know, the way plastics are moving throughout the world, there's a lot of floating debris, but once it gets smaller and smaller, they become distributed through the vertical column, and they're riding currents globally. So when we did our work on microplastics, putting all of our microplastics onto one map, our $5.25 trillion trillion particle estimate. Next slide, please. So we called it a smog of microplastics. When we look at fibers, it really reinforces that idea that we have these abundant microfibers in all waters. In the Arctic, there's a recent paper in Antarctica. We have some slides outside the gyres near the equator, and we're finding the same thing. The most abundant particles outside the gyres, the remote waters, are microfibers. So what are the sources? Next slide. So some of the sources, very simply, and I'm not sure some of the techno fixes of improving our mechanisms for washing clothes are going to improve these sources. Next slide, please. So washing textiles in rivers and streams is common around the world. I would say, you know, up to half of the planet is washing their clothes in this manner, outside of washing machines. Turf from AstroTurf, lint from dryers exhausting a lot of microfibers in the drying process, carpet fibers, shredded tarps. I just stopped by a gas station yesterday and saw a blue tarp on top of the station that was completely in shreds and picked up handfuls of blue fibrous sort of mass. So there's a lot of other sources of these microfibers, and the sink is worldwide, remote waters. So next slide, some of the impacts, we're seeing many more papers coming out of ingestion of microfibers. Here's one of ingestion in zooplankton, next slide, in crustaceans, other invertebrates. We're seeing a lot of these ingestion studies, and it makes sense. All the world's filter feeders are going to be taking these out. So some studies are looking at, one possible sink for these fibers, one pathway to ultimately sedimentation is through the bodies of these marine organisms that are taking them in and sequestering them in their bodies. So one great review that just came out, next slide please, from Tamara Galloway, looks at some of the impacts. And these were kind of well known for microplastics and proving true for microfibers as well. If you look at some of these impacts, it's everything from the transportation of these POPs, organic pollutants, intermarine organisms. I haven't got time to get into this, but this paper from Galloway is a very good reference looking at a general sort of review of the impacts of microfibers on marine organisms. And the last slide, please, looking at what we do about this. There is no silver bullet. You're going to see, I think we can categorize the solutions for synthetic textiles in these 4 ways. How we wash clothes, weave, how we're designing our fabrics, where our culture of wearing clothes and washing them as soon as they might touch the ground might be a bit excessive. And waste, how do we deal with waste textiles and the quality of textiles being made for transitional fashion versus the heirloom culture of some brands. So I think we can categorize the solutions in these ways. Again, no tech, no fix. And real quickly, so the sink looks like a smog of microfibers in all remote waters worldwide. And the source, there are many sources besides just the clothing industry. And that's it. Thank you.
Great, thank you, Marcus. And as we can see, microfibers are abundant in all aspects of life. So it's important that we continue the dialogue about solutions. So with that, I'm going to pass it over to Rachel Millar, co-founder of the Rozalia Project, to discuss the microfiber catcher.
Great, can you hear me?
Yes, I can.
Okay, great. Well, we're excited to introduce you to the CORA ball, our solution to microfiber pollution. But first, I want to give you just a quick little bit of her background. CORA was born out of the work of Rozalia Project, our nonprofit whose mission is to clean and protect the ocean. We've been working on the problem of marine debris since 2010 and address the problem through cleanup, education, innovation, and research. And it was during this research that we learned about the problem of microfibers and realized there needs to be a solution to this step. So next slide. I get to introduce you to the CORA ball microfiber catcher. This is a human-scale, consumer-based solution to the problem. And it can be used by anyone in any washing machine, and it is easy as just dropping it in the laundry. Next slide. CORA was inspired by coral, because coral does what we need done. And what we need done is we need water to flow, and we need to catch very, very small microscopic things. A standard filter really can't do both, but nature does. So next slide. The way, like I said, it's as easy as dropping it in the washing machine. Any washing machine, front loader, top loader, with or without a spindle. And this is how it works. Next slide. Fibers and hair, as a bonus, are caught up in the coral-like stalks of the CORA ball. And this is after a test load. And you'll see these look like hairballs. So next slide. When we take these off and put them under a microscope, you see it's really microfiber balls with a little bit of hair. It's just that we can see the hair with an unaided eye, and the microfibers are really too small to see. Next slide. So I can tell you about why we're excited about the CORA ball as a solution. So this is a one-time buy. We're aiming for $20, and you just buy it once. It's easy to use, like I said. Any washing machine, it really can't get easier than just dropping or tossing it in. You'll clean it yourself. So it's easy to clean, kind of like a hairbrush, and you don't need to clean it every time you use it. Some loads have more fiber than others. It's a multi-use product, so it will be usable in the dryer as a dryer ball, and we're calculating the efficiency of that, and we'll share those results when we have them. There's also no interference with the very reason you're washing your clothes in the first place. So your clothes will get nice and clean and dry with the CORA ball in there. CORA will address the whole wash load. So like you've heard before, it's not just fleece that is contributing to this problem. The CORA ball will collect fibers from whatever you put in the wash, except lace. We recommend that you do what your moms taught, like what our moms taught us, and separate delicates when using this. And we say prevents water and air pollution. And what we're talking about there is that we're catching around 15 to 30% per CORA ball, and we're keeping those fibers out of the environment. The reason we're saying water and air is that the CORA ball collects fibers from the water and keeps them from re-sticking back to the clothes. So they can't fly off your clothes when the wind blows, in which case they'd end up on the ground as runoff and back into the waterways anyway. Based on our research over the summer in the Hudson River and other papers, we believe that air pollution will prove to be a very large part of this problem. And it's important that the fibers that we stop are recovered and put in the bin, trash bin, at least for now, until we can figure out a way to upcycle them, which we're working on. Finally, there's a bonus. It catches hair and people hair and pet hair. And for us, what that means is that even people who are not thinking about protecting the ocean or whose budget or priorities don't allow them to buy something that's only for the environment, they have inspiration to use a CORA ball as well, even if it's only about keeping their pet hair from being all over everything. And materials-wise, we'll be using 100% recycled and recyclable material that's made in the US. So we can go to the next slide. We see the CORA ball not just as a stopgap for the problem, but one is inspiration for people to remember that their washing machines and all of their drains are a land-sea interface, and maybe stop putting so much stuff down them. And also to help inspire some of the great work like Sophie's doing and inspire consumer textile or commercial textile and clothing industries who are pre-consumer to go with the innovation that is going to stop this problem in the first place. We imagine that'll take some time. So we've written our patent to expand into commercial applications, inline washing machines, wastewater treatment plants, and dryers as well. And so the last slide, we are excited to announce that our Kickstarter is planned for March 28th, and our backers will be the first people to have their hands on a CORA ball. After that, we hope to have them available online in late June and work on distribution partners from there. So if you have questions or ideas for potential partners or comments, we're reachable through our website, rozaliaproject.org. Thank you for your attention, and thank you to the organizers for the opportunity to introduce you to CORA.
Great, thank you, Rachel. And now we're going to be hearing from Alex Nolte, co-founder of Stop Microwaste. Alex will be talking about a microfiber filter.
Yeah, thanks for having us. I'm Alex, and together with my partner Oliver, we have a small company where we produce our own apparel, all made from natural material. However, we also sell quite some other materials from other manufacturers in our stores, and we said, okay, we have to come up with a solution. And next slide, please. So what we did, we went in our favorite beer garden, had some creative sessions, and started on testing back in Oliver's bathroom, and just to understand a little bit more about the dimension of the problem and what kind of fibers get lost. And at that point, we started to reach out to all the experts, because we are producing our own textiles, but we are not, we haven't known anything, or not at least enough from the microfiber pollution. And we reached out to the Fraunhofer Institute, to the Alfred Wegener Institute, also to the University of California that we mentioned before, the German Textile Institute, which is very well known for that. So we slowly but surely tapped into the whole topic and came up with a hypothesis. So next slide, please. So after a lot of trial and error, we finally had a solution, which is a microfiber filter bag called Guppy Friend. And we won a gold award at the Europe's biggest outdoor show, and that was a point where all of a sudden the whole industry approached us and said, well, can we buy the patent of you? And we said, well, let's try it that way. We establish a non-profit, and everybody can benefit from that, and it's not a marketing thing. That was also at that point when Patagonia joined us and gave us a grant to make the huge investments and also do all the testing that were necessary to get it out into the market. Next slide, please. And yeah, and then we had the bag, and the bag is, we had our crowdfunding already, so we hopefully going to ship it out to the crowdfunders next week or the week after. Ollie is down in Portugal at the moment as we speak, overseeing the last steps of the production. It's a polyamide 6.6 bag, which is hydrolysis resistant. It's a monofilament, so it doesn't shed itself. We have now done it in a way that all but the little metal part of the zipper can be recycled, so you can recycle it as a whole at the end of the life cycle. But if you treat it well, it takes some time until you reach that point. So far we haven't come to that point yet, so it's not a single use. You can certainly, if you treat it well, you can use it over years. Well, we certainly had to face the challenge, which is common for all filter solutions at this point, how to get the soap and the water into the bag while holding back the tiny, the microfibers, and that they don't block the tiny holes. Well, that was, as I said, also trial and error. And what's happening is that the microfibers that do break, that they gather in the hem or in the corners of the bag. So, as I said, we are at the point where we take pre-orders. We're going to ship it out there. We're gonna have a retail. Patagonia is certainly providing some. REI is also interested in distributing them. So, well, we are very happy that we are at that point that we actually see it happen out there in the market. And maybe I should mention that the Guppy Friend does two things. On the one hand, it's reliably holds back the microfibers that break during washing, and on the other hand, it's designed in a way that less microfibers do actually break, which is also a contribution to sustainability at that point. So next slide, please. That is just like a very, very easy step how to use it. You put the clothes into the bag, you wash as usual, and then, as I said, you just take the finger, pull off the microfibers, and then you dispose them properly. So what disposing properly means is different depending on where you work. We're going to provide online a very detailed list on what to do with the microfibers. Also think about taking the microfibers back, and we have some tests going on, as Rachel also said, about what you can do with it. And next slide, please. And I mean, we know, and that was also mentioned earlier, that we need several solutions on multiple levels. We figured out during our process that there is not a washing standard for that. So together with the German Textile Research Institute, we developed the fiber loss quantification standard, which allows us to take textiles and evaluate them, or compare them, how many fibers they lose, and also what kind of fibers. So that is for us the first step to come up again with hypothesis to say what do we need to change in order to re-engineer the textiles. And I think even with the data set that we have from hundreds of washing tests that we have done so far, we can pretty reliably say if you change this and this, this and that, and you use another textile, then you would dramatically reduce the microfiber loss already. So next slide, please. So if you have any questions, please let us know. That's our team in Berlin and in Düsseldorf, and thanks for your attention.
Great, thank you, Alex. And since we did have a little bit of a delayed start, we do plan on going a little bit after 2 o'clock so that we have enough time to hear from the last two presenters, as well as asking all the questions that you guys have been putting in the Q&A. So we encourage you to stay on, but we apologize for the delayed start. So with that, I'm gonna pass it over to Adam Saslow, Senior Facilitator with CSRA and Senior Consultant to the EPA's Trash Free Waters Program, and he will be discussing washing machine filtration.
Good afternoon, everybody. My name is Adam Saslow, and as was stated, I'm the Senior Facilitator and Senior Consultant to EPA's Trash Free Waters Program, and really taken by not only the 200 people online today, but also the potential solutions and next steps that have been put forward. We're taking a little bit of a different tactic with the national program of EPA's Trash Free Waters initiative. Over the next 6 months or a year, we'll be convening a dialogue. Next slide, please. I'm so sorry. Next slide. Or do I do this? There we go. Okay. So some general introductory material on the microfibers issue and the analogies to microplastics and microbeads. But what we've been discussing in Washington is that one of the potential answers to this problem may have to come from the manufacturers of commercial and residential washing machines, the white goods sector, as we've termed it in our conversations, and between that sector and filtration experts in a variety of arenas, including some that we've heard today, we may find that we have some innovation on the horizon that helps minimize the volume of microfibers in our large aquatic ecosystems. Next slide, please. So very quickly, I know our time is short. What we're tackling right now are a series of structured interviews with leading manufacturers of washing machines, both on a national scale and an international scale. As we've learned from the outset, it was rather shocking to find out actually that there are a little more than 30 manufacturers of washing machines in the world. And so it's a much narrower group to start to get your hands around, especially relative to the enormous number of textile manufacturers that are around the globe. So structured interviews with those people, along with organizations like the Water Environmental Federation and their membership and the POTW, the Wastewater Treatment Community. In those interviews, we're trying to glean the best information possible on what is on the horizon, speaking with thought leader after thought leader in these sectors. After those structured interviews are complete, we'll be doing a situation analysis that derives from those interviews. And it may very well be that that situation analysis suggests, if not mandates, that we convene a structured dialogue to begin to innovate around potential solutions. The vision today is that such conversations would be convened over the course of 2017 in something akin to a hackathon format, locking folks in a room and saying, figure this problem out. It would be a collaboration, a non-regulatory dialogue, where we would engage the white goods manufacturers, filtration experts, the science community, textile manufacturers, and others. And again, the hope is to catalyze a group of manufacturing and other champions to establish technological solutions for filtration and begin to resolve the problem. Next slide, please. As I said, at this point, we're in the structured interview phase. And if you out there among the 200 want to participate or know of individuals who would want to contribute to the early stage development of this collaborative dialogue, please write to me. The contact information is there for myself and for Bob Benson, the team leader for EPA's Trash Free Waters program. I'll just do a quick shout out to the others who are leading in this EPA effort. Trash Free Waters, I mean, without the leadership of Josh Kogan, particularly in EPA Region 2, he's catalyzed this dialogue today. Each other region in America has their own regional coordinators, and they're accessible to you as you look to explore what EPA is doing in this space. I think that's about all I've got here. We can probably turn to the next speaker and preserve some time.
Great, thank you, Adam. And last but certainly not least, we have Wendy Barrott, Manager of Research and Innovation for Great Lakes Authority, and she will be discussing hidden costs of wastewater treatment solutions.
Good afternoon. Okay, am I on? I'm assuming I am.
Yes, we can hear you.
Okay, can I have that next slide, please? This is an aerial view of the Detroit wastewater treatment plant. This is the size of a facility that takes to serve 2 million people. It's obviously located on the Detroit River. It's a big plant, 650 million gallons a day. During wet weather, it can push up to 1.7 billion gallons a day through it. Generates 450 dry tons a day of biosolids. It's your basic conventional plant with the exception that it uses high purity oxygen activated sludge. Next slide, please. This is just a basic diagram of a conventional wastewater treatment plant to give you an idea of how they work. The influent, everything that goes into the sewer, whether it be your sanitary sewer or your combined sewer that also accepts stormwater, winds up down at the plant, everything. 2x4s, motorcycles, you name it, they're there. The first thing we do is we lift it up and then we take out the big stuff on the bar racks and we run it through a grit chamber where it drops out the sandy type of particles. It then goes to a primary settling basin where the water is quiesced and the heavy solids go to the bottom and then the scum floats. It then goes to secondary where we remove the soluble organics. So basically we use microbes, which we like to refer to as Joe the bug. And we put some air in there and the bugs just have a good time taking the soluble organics out of the water, making clean water, and they grow their bodies so that there's a larger biomass at the end. Then it goes to the secondary clarifier, the sludge sinks to the bottom, it goes to sludge thickening. The treated water then goes out and it's disinfected. And then the chlorine is taken out. The sludge is thickened and blended. And because we're a large plant, we have multiple ways of getting rid of the sludge. It can go to an incinerator. The ash goes to a landfill. It can go to a biosolids drying where we do beneficial agricultural land application. We add lime where it goes to the landfill. Next slide, please. So here, you basically have some pathways here. You have your treated effluent. One of the first studies is that the Detroit wastewater plant can remove 95% of the fibers. But what we don't know is, does chlorination change the properties of the microfibers? It might make them worse or better than when they were when they came down the sewer. The residuals, the grit gets landfilled, so you have air exposure. The biosolids are landfilled, air exposure. The land application, you have runoff and air exposure. And when they're incinerated, you have the byproducts of incineration. And we don't know what the impact of the microfibers are on the soil. During wet weather, you're only partially treating your flows. There's not a wastewater treatment plant in the country that can handle wet weather flow and dry weather flow at 100% treatment. So we do a primary treatment on it. And so we also have some CSO basins, and then we also have a large number of outfalls that don't get any control at all. So what we don't know, does the secondary treatment efficiency remain the same during a wet weather event when the flows are much higher, or do we have more microfibers washing through? And then, what are the microfibers in the wet weather flow to the storm sewers doing? Next slide, please. So if you put on your thinking cap as an engineer, which I am, where would I take it out? Well, the study showed that about 55% of the fibers came out in the first step, which is grit removal. So we could beef up our grit removal. We could add a degritter, cyclonic thing, back of the envelope calculation. And these are just like, okay, if I had to put this in, these are very rough numbers, actual cost would be much higher. So 250 million, it would take at least 10 to 15 years from the date we had a regulation, and we wouldn't do this kind of expense without a regulation. What we don't know is, would this even work? What would the capture efficiency be? Would it need to have a chemical addition? We don't know if it'll fit. Microfibers will remain in the grit, and it might hurt reuse opportunities for the grit. Next slide. Well, another thing we could do is we could treat the whole effluent, the stuff coming out after right before disinfection, with a media filter. It's a sand filter. It would treat 100% of the dry weather flow. Again, wet weather flow is escaping. estimated this at $300 million. The time would be at least 15 years. But sand filters don't get out 100% of the microfibers. So if they're really that bad, and if they're that bad for the environment, we'd want to get out 100%. Okay, next slide, please. So then number 3 solution, and this is like the Cadillac. It would be membrane filtration. It would capture 100% of the dry weather flow. My back of the envelope calculation puts it at the order of 900 million plus. It'd be hard to squeeze into our plant because we're landlocked. It would take much longer than 15 years to get it done. And it's basically a complete revamping of our whole treatment process. But the unfiltered wet weather flow remains, and the fibers remain in the biosolids. Next slide, please. Well, what do we do with these pesky residuals? Well, we could burn them, and we can incinerate them, and that's kind of what we do now. That's a picture of an incinerator there, puffing smoke into the atmosphere. Incineration is expensive. It's high operating maintenance costs. It contributes to most air quality problems, and the trend is to move away from them. And if we do this, we lose all of the fertilizer benefits of the nutrients. We could run it through pyrolysis, which is expensive. It allows some energy recovery, but microfiber destruction has not been evaluated on this. And then there's anaerobic digestion, which is kind of standard for solids, but the microfiber destruction has not been looked at, and the residuals, the problems still remain. So I wanted to just go over this quickly and leave you with the understanding that to do anything in a wastewater treatment plant is a very large civil engineering construction project that takes a very long time to put together, and it's very expensive to do. And all of these costs get rolled into the cost that the ratepayer pays for wastewater treatment. So really big jobs. Next slide, please. So, but we have a long history of impacts from consumer products. So what have we done in the past? Well, we have the control of the product content approach, which is a federal regulation. You know, we did it for foaming. We've had to do it for eutrophication. We've done it for some carcinogens. And then most recently, the microbeads have been taken from the products. Then there's also the tried and true source control, whereas each individual municipality that has industrial sources on it, they permit the industrial sources. And so we look for any of the bad things that come through, and we tell them you can't put them through there. So we can handle it that way, but it's not going to work for microfibers. And then next slide, please. And then, you know, we have this history of manufactured products creating nuisances. And I kind of think that this is kind of the model that the voluntary manufacture change might be the model for the microfiber. We have had a big problem with non-woven flushable wipes in the collection system and at the wastewater treatment plant, because these non-woven wipes, they don't fall apart in the water like toilet paper or paper towels or Kleenex. They clog up building plumbing, they clog up the laterals, they clog the sewers, they clog our pumps. They don't get captured in the bar screens or grit removal, they just slide right through. Haven't found a shredder yet to protect a pump that can handle these materials that will rip them apart. And it necessitates increased operating and maintenance costs for us and for all the PLTWs that have to handle the collection systems. So it's expensive. So the utilities got together, and they're working with the manufacturers to try and solve this problem. I don't know if they're to prototype stage yet, but basically the solution for this one was, you know, maybe we need a cloth that's not so strong. So they're looking at ways that they could substitute a cloth that meets the needs of the duty of the product without harming the wastewater treatment plant system. And that is the end of my slide, I believe. Thank you.
Great. Thank you, Wendy. And thank you to everyone for being patient with us today. If there's one thing science and innovation teaches us, it's to be flexible. So for the sake of time, we are going to move right into a Q&A period for those panelists and viewers who are still able to be with us for the next couple of minutes. So for the first question, this is directed for Wendy. Are there any insights on the role that wastewater recycling can play as a part of the solution?
Wastewater recycling is going to it's going to create the same problem as kind of the residuals to the land does, because the wastewater recycling, you're going to use it somewhere, And in a lot of cases, it goes to irrigation or some lower use in drinking water or residential homes. So you wind up with it going onto the land. So they're still going to be released into the environment.
Great, thank you. And this next question is for Sophie or Beth. Are there any new polymer/fiber chemistries being studied where the fibers might be microbially degradable in marine or wastewater environments?
Yeah, it's Sophie here. I think that's a really good question, because there seems to be quite a lot of confusion around whether a biodegradable fibre would actually be better. So I think we have to be really careful about how we actually use that, because some of the biodegradable polymers that are out there at the moment are still potentially causing harm at the marine life. So I think there's a lot more work that needs to be done to look at that before we can make any statements on it. But yeah, it's brought up many times, but I'd say until we've got further research behind it, and I think it would be a polymer by polymer, case by case situation, but nothing conclusive at the moment, and I would say that it's not an obvious solution for us.
Yeah, and I would say, this is Beth with OIA, on a bigger picture perspective to add to that. One thing to make clear here is that you know, natural fibers like cotton are shedding, as well as synthetic fibers, like, for example, from recycled PET, recycled plastic bottle fabric. And so I think much more research needs to be done, you know, to really understand the effects of those different fibers shedding. I think a lot of effort has been put around the microfibers, but certainly cotton is shedding as well. And as just the very last wastewater treatment plant study indicated, you know, you even have fibers from toilet paper and tampons and other refuse that are going into the oceans and waterways as well. And so all of this needs to be studied, and then just recognizing, at least from the perspective of the apparel industry, that every choice around fabrics has a trade-off. So you know, so you can either choose, you know, a recycled PET fabric that's, you know, preventing plastic waste from perhaps going into landfill, and, you know, recycling plastic bottles and so forth. But, you know, or you can also choose a natural fiber like a cotton. However, that brings with it its own set of challenges. You know, cotton is one of the greatest uses of water in the world. And so if you're talking about a bigger picture water use problem, you know, cotton is not the best choice around that. And so just recognizing that there are all these different trade-offs, and it's not just as simple as, you know, shifting from synthetic to natural fibers, for example. We have a lot more research to do around all of this, as Sophie indicated as well.
This is Rachel. If I could just jump in real quick to say that we also designed the CORA ball for that reason as well, that the more we looked into textiles as a whole, the more we realized we just didn't want any man-made textiles in the bellies of plankton and in the bellies of sea creatures, because of the chemicals and dyes associated with even the natural. So that we have designed CORA to be an equal opportunity microfiber catcher for that exact reason.
Thanks, Rachel. And following up with Rachel and Alex, the fibers from the CORA ball and Guppy Friend must go somewhere, possibly the trash can, in which case they still end up in the environment. So that raises the question, to what extent do microfibers entering the environment through this part of the waste stream that goes into the landfill?
I mean, in Germany that's pretty easy, because you can easily put it in the household trash, and it's going to be burned. That's, as I said, it's different in different sections of the world. And yeah, as I said, we're going to provide a list for that. For now, we have a box where you can collect the microfibers, and then we take it from there. So we talk in Germany also, we talk a lot with retailers who think about taking back the microfibers. So I think we're going to see some smart ideas around what to do with the microfibers in the foreseeable future.
And that's cool. That's what we're trying to do as well. We're considering that putting it in your trash bin is better than just not doing anything. Though it's only the next step, and that the real holy grail here on the back end would be to find an opportunity to not just recycle these, but to upcycle them.
And Rachel, what is the capturing efficiency of CORA?
what we're getting in our testing is about a 15 to 35% recovery of fibers per CORA ball, and we're testing how that's, if you put 2 in, is it twice? If you put 3 in, is it 3 times? And you know, I just want to note that that's the number we think is important. Whatever number actually goes in the bin is the number that's most important, because that's the number that can't be stuck to other clothing that really truly is recovered.
Great. And shifting back to the wastewater treatment facility side of things, Wendy, what about a tax on synthetic textiles to pay for wastewater treatment facility upgrades, an EPR model as opposed to ratepayer upgrades?
You know, it's certainly something that we would not rule out. It would have to be a pretty significant tax, and it would be fair in that it would land on the people who are purchasing the products, but I have not looked at the economics of that, so that remains to be looked at.
Okay. And then Sophie, what type of spectroscopy appears to be most efficient? Can you use the scanning electron microscopy to determine synthetic versus cellulose fibers?
Yeah, it's a good question actually, because what we're doing on the polymer and level, we're doing the SEM on the fabric side, because what we get is a very flat image, and we're doing sorry, the word slips my mind here, but we're doing more three-dimensional imaging on the yarn and the polymer level, so we can actually get a three-dimensional visual effect of what's actually happening there.
Okay, and finally, is for Sophie again, is the nanotubes / nanospheres technology a potential threat, would you think?
The nanosphere technology, we're not actually looking as far down at the nano level at the moment. There's some work going on at Plymouth University at that level, but I think we've got a lot to learn at the kind of regular level before we get down to that sort of scale.
Okay. All right. Well, I want to thank all of our panelists today for taking the time out of their busy schedules to talk to everyone. This webinar was recorded, so we'll be sure to send that link out to everyone probably at the start of next week. Again, I want to thank you all for being so patient with us in the beginning, and I hope that we can further this discussion about microfibers in the coming months especially. Thank you so much, everyone.